Okay, welcome back everybody to another video. In this little one, I'm going to be talking you through this exam question, which is coming from the 2023 Exam 1 from Vika. So starting out here, this is an Exam 1 question, so no calculators are allowed for this. And we've been given this particular function, f, which has a domain of negative infinity to 1. So we can see that the x values go from all the way from negative infinity, which is way down here, up to 1, which is here, and we can see that we have included that 1. That's why there's that solid dot just there. And it says that the rule for this function is here, so it's x squared minus 2x. And this is part of the graph of y equals x, which has been shown on this graph here. So the first question from this requires us to state the range of f. And the range is basically the set of y values that this particular function can have. So if we have a look at this graph, the set of y values is going to be from here up to infinity. We can see they're the y values of this graph that have been included here. So for example, at the point when x is equal to 1, y is equal to negative 1, it's important to note that that's included in the range here. So we can say that the range of this function is going to be negative 1 up to infinity. There's always a round bracket around infinity because we can never actually reach infinity. There's always this square bracket if we're including a point. And notice this sort of symbol here that looks a little bit like an E that says y is an element of the set from negative 1 up to infinity. So that's the answer to part A there. Now, the next question asks us to sketch a graph of the inverse function on the axis above, labeling any endpoints and axial intercepts. So we need to make sure we do what the question says and label endpoints and axial intercepts. Make sure we don't miss those, right? So here's how you can answer a question like this. I would recommend drawing a line down the diagonal like this. That blue line that I'm drawing there is the equation y equals x. And what we do when we basically take the inverse is it's like we're swapping x and y with each other. So the x-axis is going to become the y-axis, and the y-axis is going to become the x-axis. It's the same as taking this graph f of x and reflecting it in the line y equals x to give us the inverse function, f dash x. So let me just try and draw a graph of the inverse function. I'll do it in orange. So we're going to say that y is equal to f inverse of x is just going to be that black line reflected about that blue line. So for example, if we were to take this point here, which is the point 1, negative 1, that's going to end up at negative 1, 1. Basically, we just reverse those two coordinates. It's going to end up right here at negative 1, 1, right? If we were to take this point here, 0, 0, well, we swap those two coordinates, 0 and 0, and we're just still going to get 0, 0. So that point is actually included on our graph as well. And if we were to look at another point from this black curve that we have here, what I'd recommend doing is using the grid lines here. So for example, you can see this particular point, negative 1, 3. In fact, I should probably not have these in orange just to confuse you. So let's say we were to look at this point up here. That point has the coordinate negative 1, 3. That's that point there. And again, for the orange graph, the resulting point is going to be just basically flip those two values. So it's going to be 3, negative 1, which is over here. So that's the point 3, negative 1. I've just chosen these points just to kind of illustrate what we're doing. You don't need to label all of those. The only ones that you need to label are the endpoint, which is negative 1, 1, and the intercept, which is 0, 1. But your line should pass through this particular point, 3, negative 1. So always use your grid lines to your advantage. That's what this curve looks like, essentially. And just make sure it's nice and smooth there, like that. All right, next question is, determine the equation and domain of the inverse function f inverse. So to start this question out, let's switch back to black and go up here, and I'm going to just start by writing out the equation. Y is equal to x squared minus 2x. So that's the equation that we've been given here. Now, our goal here is, like we said, we're going to swap x and y. So x is going to become y and y is going to become x. So here's what happens when we write the equation like that. Instead of putting an x here, instead of putting a y here, I'm going to put an x. Instead of putting an x here, I'm going to put a y. Instead of putting an x here, I'm going to put a y. So the equation will become this, right? So it's the same equation, just I've switched the two variables around, x and y. Now, we are going to have some trouble here. So you may have gone down some rabbit hole of, okay, well, we've got these y's here. We could try and factor out the y. And then we can see, all right, we've got x equals y times y minus 2. That doesn't really seem to help us in terms of rearranging this equation. So we need to come up with a better way of doing this. And a couple of ways that you might use to answer this question. I'm going to give you kind of two different methods to answer this question. Method one is completing the square. And method two is going to actually involve using the quadratic formula in a slightly unconventional way. So first up, let's have a look at completing the square. So if we have this equation, one way that we could make the algebra easier for ourselves would be to complete the square, because essentially our goal here is just to figure out what is y equal to, right? Like we want to make y the subject. So what we can do here is we can complete the square, which involves adding half the coefficient of just the linear term here, y. So half of that is, well, half of 2 is just 1, right? So half of 2 is 1. And that's going to be squared, and we minus that term squared. That's what completing the square looks like. We just take that term there, halve it, and then square it, and we're going to add that, and we're also going to subtract that. The first three terms in that little expression that we've created there is a perfect square. Why is that? Well, let's simplify it. This is y squared minus 2y plus 1 minus 1, because of course 2 divided by 2 is 1, and 1 squared is also 1, right? So those first three terms there, if we have a look at them, well, y squared, how do we factorize this, right? Like, well, we'd think two numbers that add to make negative 2 and multiply to make 1 are going to be negative 1 and negative 1. So we can say that we can factorize this like this. Yeah. So because that's a perfect square, if we were to expand those brackets, we would get this thing up here. That's how we can factorize it. Okay, so now we can see that that is equal to x. And what remains to do here is just some little algebraic manipulation to rearrange this equation to make y the subject. So what we might do is we would first plus 1 to both sides, like that. And then we need to somehow get rid of that square. You just got to be really careful when dealing with the squares. The inverse is, of course, the square root. But when we do take the square root of both sides, we need to remember the plus or minus, because there's a positive and a negative root here. So that cancels with that. And on the this equation kind of just becomes y minus 1 is equal to plus or minus the square root of x plus 1. Yeah. And finally, we can plus 1 to both sides to find that y is equal to 1 plus or minus the square root of x plus 1. And now we need to just decide, is it the plus or is it the minus, right? So what we might think is, all right, so this graph up here, the domain of this graph was negative 1, 1. Now you need to know the domain of f is equal to the range of f inverse. And similarly, the range of f is equal to the domain of f inverse. So what does that kind of imply here? Well, it implies that this domain here, the domain of this original function we started with, that was negative infinity to 1, right? So it's like the left side of the parabola, which means that we're dealing with that as the range of f, and that's only going to be the range, so the range of f inverse. That's only going to be the range of f inverse with the negative root here, or you can think about it as like we're dealing with the left side of the parabola, so it should be that. So we should see that actually we're going to reject the positive root, and we're going to have this as our rule for y. And in other words, that's the rule for f inverse. So for f inverse of x, it's equal to what we can see here. And just to double check that, like, what are the possible values of x that we could have in here? Well, that is actually part of the question, because it does say, what is the domain? What are the possible values of x that we could put in here? Well, the domain of this function is going to be, think about this bit here, right? That thing inside of the square root has to be greater than or equal to 0. So that means that x needs to be greater than or equal to -1. So we can say the domain is going to be -1 to infinity, and just notice that there's a round bracket around a square bracket around -1, because the square root of 0 is 0. That is perfectly defined. And of course, the range of this is going to be 1 to -infinity, or sorry, -infinity to 1, written in the correct order. And that's what happens when we have this negative sign here. The square root could spit out as large of a number as we like. We have 1 minus a large number, that becomes a negative number, so -infinity. All right, and as promised, just to show you another way of getting that rule, something else that you could have done with this equation, just jumping back to here, is let's say that's our equation. Something else that you could do whenever you have a quadratic like this is actually just treat it as a quadratic and just don't even worry about the x. So what I mean is I'm going to minus x from both sides, like that. And you can see there that I've now created a quadratic equation in terms of y. And how do we solve a quadratic equation? Well, we can just use the quadratic formula. So we know that y is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the quadratic formula. You do need to memorize it. We can then take these values and substitute them in. So in this case, our b term is -2. So negative b is actually going to be +2. So it's +2 plus or minus the square root of, well, that is -2 squared minus 4 times 1 times -1. That's 4 times a times c. Sorry, not -1. That's a mistake there. Let's go back to that. It's not -1. That's negative x, I should have said. Why is it negative x? Well, we're dealing with a quadratic in terms of y. X is just a number. We're just treating it as though it is just any other number. So it's going to be a square term there. And then we're going to divide all of that by 2a, and 2a is just 1, the coefficient in front of the square term out the front there. So if we simplify that down, we get 2 plus or minus the square root of 4 plus 4x, right? All divided by 2. Okay. And how can we simplify that further? Well, we can see that there is a common factor of 4 inside this bracket here. So hopefully I don't run out of space, but let's see if I can just quickly squeeze this in. 2 plus or minus, well, the square root of 4 times the square root of 1 plus x. I've just factored out the square root of 4 term there. And of course, the square root of 4 is just equal to 2, isn't it? So that there is just the same as 2, and that's going to cancel out with this 2 down the bottom here, because 2 divided by 2 is just going to make 1. 2 divided by 2 is also going to make 1. So we can see we still actually end up with, and I know I'm running out of space, we still end up with the same expression that we ended up with over here when we simplify that quadratic. So in the end, we will end up with 1 plus or minus the square root of x plus 1. And you can see that you then need to use your intuition to work out that it is the negative root and that the domain is this. That's just sort of an alternative method if you really don't like completing the square. Just so you know, basically, that's what the quadratic formula is. It is completing the square. So it's always a nice little shortcut for you in times like this when you just don't want to use completing the square. Anyway, hopefully that little video was useful for you guys. That's sort of 2 approaches to that last question from the 2022 exam. And yeah, I will see you guys soon. Have a good weekend.